Welcome to the video for lesson 10.4. Please take the time to write in the learning target. The learning target for this lesson is I can use inscribed angle properties to solve for angle and arc measures. So inscribed angles are going to be slightly different than the central angles that we've been dealing with in circles up to this point. And in our vocabulary section we have an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So again, we want to make sure that we know where the vertex is for the inscribed angle and how it is created. It's created by two chords, and to compare that to the central angle, a central angle has its vertex at the center, and the sides of that angle are going to be two radii. So we're going to take some time to compare the two and make sure we know the difference between a central angle and an inscribed angle. Okay, next, we want to go through this next vocabulary term here. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. That's just to refer to the arc itself from an inscribed angle. I'd also like to introduce the first of several theorems that we have for this video. The first one says, measure of an inscribed angle theorem. That's theorem 10.7. And it says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So inscribed angle, half of its intercepted arc. Now to compare that to a central angle and the arc of the central angle, in the central angle we have two radii that make up that arc. Okay, so, that angle. If this is 40 degrees here, right, the angle itself, the arc is also 40 degrees. But what this theorem is saying is that the measure of an inscribed angle is 1/2 of its intercepted arc. Okay, so we have to know that difference between the central angle and the inscribed angle and the arcs that are with both of those. Okay, next we have theorem 10.8. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. We're going to have some practice problems having to do with this particular theorem. It also states here a polygon is an inscribed polygon if all of its vertices lie on a circle, and the converse of that is the circle that contains the vertices is a circumscribed circle. Okay, so we're going to take a look at a couple of examples of those as well. Theorem 10.9 states if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. So this only works with right triangles. If that right triangle is within a circle, then the hypotenuse of the triangle is the diameter. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. And this, of course, we'll practice and have a practice problem on that one. Okay, we have one more theorem to take a look at. The last theorem is 10.10. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. All right, so let's take a look at our first example. Example 1, use inscribed angles. So use the inscribed angles to find the given measure. If we want to find the measure of arc YZ, that's this arc right here, we first need to identify the inscribed angle or the measure of the inscribed angle in order to find the measure of that arc. So these two chords, this chord XY and this chord XZ, are creating an angle, and that would be called an inscribed angle. Okay, in the directions it says use the inscribed angles to find the given measure. So this is an inscribed angle because its vertex is on the circle. All right, so because its vertex is on the circle, we're going to have to double the measure of that angle. So if the angle YXZ equals 50 degrees, then we need to double that. So we're going to multiply that by 2 to find the measure of the arc. So the measure of the arc is going to be 100 because we had the intercepted arc is from an inscribed angle. Now we need to find the measure of this angle. All right, so the measure of angle YWZ. We start at Y, we go to W, we end at Z. So what is the measure of that inscribed angle? Well, you can see that the chords end at Y and at Z, so it's going to make up that same exact arc. Okay, so if that arc is 100 degrees, then we would have to divide by 2 to find the measure of the intercepted angle. So the intercepted angle is 50 degrees, the same thing as it was for the angle YXZ. If it shares the arc out here, then that means the angle is going to be the same measure. Please do these 2 practice problems. We're still going to be using this exact diagram for those 2 practice problems. Okay, if you would please turn your paper over, I'd like to look at example 2, use a circumscribed circle. And in this problem, we're going to be using theorem 10.9. And 10.9 says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And I want to read through the problem and then I'll explain how that theorem goes with this particular problem. So it says here, you want to illuminate the front exterior of your house with spotlights that have a 90-degree range of projection. So 90 degrees, that reminds me of a right triangle. You position one spotlight as shown to maximize efficiency. However, it's not quite bright enough, so you want to add additional lights. Where else can you place the spotlights in order to get the brightest results? Well, if the spotlight has a 90-degree range, then I want to assume that I'm going to make a semicircle here and that triangle is inscribed in the semicircle. Remember then, this is the diameter of the circle. This right here will be the diameter. And where can I place some other spotlights to light up the house even more? Well, any place that the right angle can be created on that semicircle. All right, so I can make a a right triangle from here. This is a right angle, so I can have a spotlight here and I can have a spotlight here. Basically what I'm doing is I'm using the semicircle to determine where I can put those spotlights, because remember, any right triangle inscribed in a semicircle is going to have this as the hypotenuse. The diameter of the semicircle is going to be the hypotenuse. So I could add another one over here. As long as it is going to be a right triangle, those are the points at which I could add in more spotlights. Okay, so that's theorem 10.9 in a practical application. Now I'd also like you to practice this one, which is a little bit more challenging because it says in example 2, explain how you would position the spotlight if you wanted to illuminate both the front and right side of the house. So the front and the right side. So I'm going to just suggest that you extend the range over here, and you're probably going to want to draw a semicircle in about like this so that you can add more spotlights over toward the right side of that house. That's just to get you started, but I want you to finish and add some more spotlights to illuminate the front and right side of the house. All right, our last example is that we're going to be using theorem 10.10, and I'll remind you that theorem 10.10 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Well, we remember what supplementary means. It means that the angles add up to 180. So these two angles, P and 110, have to add up to 180. So what's the measure of angle P? Well, P plus 110 has to equal 180. And so therefore P is going to be 70 degrees. So if P is 70, we could also find out what angle Q is, because we know that Q plus 95 has to be 180 also. So Q is going to be 85. So all you have to do is make sure you remember that rule. Again, theorems just mean, the word theorem just means a rule. So theorem 1010 says that these two angles are going to add up to 180. And these two angles are going to add up to 180. So I need you to solve for each angle. Well, it says each angle. So once you solve for y, make sure you plug it back in. When you solve for x, make sure you plug it back in. And then you can tell me what the measure of angle Q is, the measure of angle R, the measure of angle P, and the measure of angle S. So you're looking for those 4 angle measures once you set up your equations for solving for y and solving for x. Okay, if there are questions, I'll take those in class, and thanks for watching.